everybody, this is Miss Green, and I am going to review section 1.3 for you. So this stands for lesson 1, part or section 3, okay? It's talking about what are constraints, and these pages are also in your student workbook, but I'm just gonna review them with you here. So it starts out by saying a constraint is something that limits what is possible or reasonable in a situation. So, for example, one constraint in the pizza party might be the number of slices of pizza each person could have, which it represents S here. So we could say that S is less than 4 to say that each person can get fewer than 4 slices. Looking at the expressions you wrote when planning a pizza party earlier, we're going to use the same variables over here, okay? Choose an expression that uses one or more letters. And B, for each letter, determine what values would be reasonable. For instance, could the value be a non-whole number, a number greater than 50, a negative number, or exactly 2? So I'm going to create an expression that uses one or more letter. So over here, I'm going to use this one down here. Actually, I'm going to use that we know that each main dish is $7.50. And we know that the number of side dishes are $4.50. And I know that's going to equal the total cost. Okay. So for each letter, determine what values would be reasonable. So for a main dish, it didn't tell us that we could order a half. So to me, I would say the only thing for main dishes would be able to be whole numbers. Okay. Same thing with side dishes. I think that side dishes would only be able to be anything greater than 0 because technically you don't have to order a side dish, but you could. So again, also I would say whole numbers. But when it comes to T for total cost, okay, that would be any number except negative numbers because we could have decimals, we could have fractions, we could have anything along those lines. Part 2, write an equation or inequality that represents some constraint in your pizza party plan. So again, if I was using this story, because I don't have the ones we did in class, I could say that if I was talking about my meal and I know I'm spending $7.50 for the amount of main dishes and $4.50 for the amount of side dishes, okay? Write an equation or inequality that represents some constraint in your pizza party. I'm going to say that if I only have $50 to spend, I can't spend more than $50 on my main dishes and my side dishes. So in this case, you would have to figure out what are the numbers and the amounts of main dishes and side dishes that you could buy without exceeding $50 because that's only how much I have to spend. Next, expressions and equations and inequalities are mathematical models. They are mathematical representations used to describe quantities and their relationships in a real-life situation. Often, what we want to describe are constraints. A constraint is something that limits what is possible. Just like in the last problem where I only had $50 to spend, okay, my constraint was the amount of money I can spend has to be less than or equal to $50, okay? For example, when planning a birthday party, we might be dealing with these quantities and constraints. It says the number of guests are 20 people maximum. The cost of food and drinks, $5.50 per person. The cost of a birthday cake, $40, okay? And so on and so on. We can use both numbers and letters to represent these qualities. For example, we can write 42 to represent the cost of the entertainment, but we might use the letter N to represent the number of people at the party and the letter C to represent the total cost in dollars. We also can write expressions using these numbers and letters. For instance, the expression 550N is a concise way to express the overall cost of food. If it costs $5.50 per guest and there are N guests, then I know this expression 550N represents the amount of money I'm spending on guests for food. Sometimes a constraint is an exact value. For instance, the cost of music is $15. Other times, a constraint is a boundary or a limit. For instance, the total cost must be no more than $180. Some symbols, such as less than, greater than, and equal to, can help us express these constraints. Okay? So in this case, n, the number of guests, has to be less than or equal to 20. I know that the cost of food and drinks being $5.50 per person is going to multiply out evenly. Okay? And it doesn't have an inequality. And so on with the rest of these expressions. Equations can also show the relationship between different quantities and constraints. For example, the total cost of the party is the sum of the cost of food, the cake, and the entertainment. Okay, so this is music and games, entertainment. We can represent this relationship using the equation C for total cost is the amount of food plus everything else. Deciding how to use numbers and letters to represent quantities, relationships, and constraints is an important part of the mathematical modeling process. And it's all what our lesson 1 is all about. Making assumptions about the cost of food per person, for example, is also important in modeling. A modeling such as C equals 550n plus 82 can be an efficient way to make estimates or predictions. When a quantity or constraint changes, we know what we want to know something else. We can adjust the model and perform a simple calculation instead of repeating a serious calculation. So for example, if I wanted to calculate in this equation, if I invited 50 people to my party, even though it said I had to be less than 20, so let's say 10. So if I want to find the cost of 10 people coming to my party, I could plug 10 in for n, the number of people, and see how much it would cost. Some vocabulary and glossary entries to add to your brain for the next couple weeks. Remember, a constraint is a limit on the possible values of variables in a model, often expressed by equation or inequality. Okay? Think of your constraint as always your limits. How much money you have, how many people you have, things that you really can't go over. And last, a model, a mathematical or statistical representation of a problem from science, technology, engineering, work, or everyday life used to solve problems and make decisions. So some of my favorite models are pictures, tables, graphs, equations, and things like that. Anything that's going to help you solve a problem is an example of a mathematical model. Have a great day.